Welcome to Converge. My name is Danilychev, and we're going to discuss Citrix Provisioning Services from perspective of developers, IT pros, and pretty much what can we do that's available at our fingertips. And today we're going to demonstrate one of the aspects of PVS, rapid image provisioning, which is available for both physical and virtual machines. And in fact, Citrix SDK's availability creates a great opportunity to expose Citrix PVS image provisioning and image switching options to end users, where any perceived complexities associated with modern IT infrastructure are hidden and are foolproof, in essence, at the same time. Image computer classroom setup, where physical or virtual machines deliver diverse dedicated environments, are pretty common. While virtual implementations do have more image swapping capabilities and options, both physicals and virtual machines quite often are impacted by either complex or error-prone application provisioning mechanisms or slow disk cloning techniques. Situation with PVS deployments is quite different. Due to a real-time image streaming approach, the ability to deliver a different monolithic image by the time machine reboots with its new identity is usually very reliable and measured in a sub-minute timescale. Image reassignment can happen while machines are in use. One reboot and the new image is powered up and ready for users to consume. There are a couple SDKs available, so there is a barcode on the screen that will allow you to take a look at that. In essence, there are three different SDK flavors. Here we're going to focus on PowerShell, so it's easily consumable, and we will be able to create several different flavors of applications. Let's jump into it, and here we go. We'll have to configure a few things first. So I'm going to drop installation for Provisioning Services console, which will enable our access to PowerShell. And we're also going to drop here Citrix Zen Center, which will allow us to connect to Citrix Hypervisor, because this is where some of our test machines are provisioned. So let's go first for PVS console. Notice I have all the prerequisites already in the same folder, so this is fairly uneventful installation. And real quick, let's install Citrix Zen Center. And let's go to our brand new Citrix Provisioning console. All right, so wonderful. And I will talk a little bit what's on the screen, but pretty much we have Citrix console right here. And let's launch our Citrix Zen Center so we can connect to the hypervisor that hosts machines for this demo. So what do we have? So we have Provisioning Server actually is running on our hypervisor. So we pretty much just have one hypervisor. We have 20 virtual machines configured, and those 20 virtual machines actually are mapped to our demo farm, to our Provisioning Server farm. And again, we're going to look for the most part device collections, accounting, geometry, and history. And you can see that we have a few machines assigned to history, only one machine to geometry, and there are some machines assigned to accounting. These machines with their respective MAC addresses are pointing to a disk that's being streamed towards them via Citrix Provisioning Services. So I have an image, and by the way, if anybody's wondering why AMD is there, this machine just has happened to have AMD processor. So that image is Server 2016. Geometry, let's take a look what image is there. Right, looks like it's Windows 10 Enterprise. And then for history, we'll have a completely different image as well. Yeah, happen to be Server 2016. So we have one Windows 10 and two actually distinct 2016 servers. Okay. So if we go to, let's say, PC00, so what we can do, we can start it. Let's go to the console here. And what will pretty much happen is machine will boot from Provisioning Server. In fact, if you take a look at local storage, this local machine actually has no local disk whatsoever, right? That might not be the most efficient way of deploying machines with PVS, because you probably like to have some local cache so you don't transmit bits unnecessarily across the wire. But it demonstrates the strength of this solution because you can create pretty much empty virtual machines, no disks attached, stream them from PVS. The cache can be in RAM, right, or maybe behind your provisioning server. So it's quite easy to deploy very large number of machines based on the handful of images. And if you need to switch those images, you repoint them, those machines, to different images, restart them, and you will assume a different identity. So let's take a look. Oh wow, so we happen to have a geometry image. So that's PC000 was gives with the image for geometry class. And let's take a look. If we refresh our geometry collection here. Okay, so we have our device is already online, right? So if we do login, okay, so what we can do, we can actually send a message to this target device. Welcome to our conference, exclamation mark, and here's the device that we're going to, yep. So pretty much we were able to send this message. So that can be done by collection. It can be actually sent to device individually, but those facilities are built into provisioning services. So there's really no magic about it. It's a well-established technology. Okay. So let's do this. Let's reboot this machine. So go back to target device. We can restart this device right now. Right, but those facilities are also built in, right? Notice we're restarting the device. Okay. So that was fairly uneventful. So let's take a look at, let's say, accounting. So we have device 10. Looks like it's a good candidate. Notice if we try to start that machine from provisioning server, so if that device was physical, we'll actually be able to do it. However, we can jumpstart that machine from our hypervisor, right? So in other words, give it kickstart. And yes, we're streaming it right now. So in fact, if we go here, refresh our accounting picture, well, not yet. So machine is not out of the woods yet with the network booting. Okay, so let's see if this machine is okay. All right, this machine is still good, right? So we just rebooted it. Oh, and by the way, well, the device boots, so we can go back here. We can actually shut down machine from here. Let's say restart, shut down, send a message, so we'll shut it down. Okay, so as you can see, that machine will be shut down. Now what's happening with this guy? All right, we have accounting class. So in other words, machine 10 has completely different identity. It has accounting, and machine 00 was just shut down. So let's refresh our geometry collection. And by the way, when devices are organized in collections with provisioning services, they don't necessarily need to stream the same image from the same pool of provisioning services. So they can actually be getting the individual image, but usually it's customary to have a collection that deals with a pool of provisioning services streaming a particular image, which makes it very efficient, right? So provisioning server does caching of the bits, so it does not need to go to the disk unnecessarily. There's also subnet affinity capabilities where we can stream from provisioning server, which is the closest one to the target, and so forth. So there are some many interesting techniques that are being used over the years, and it's worth actually for you to take a look into it. But what we're going to do here, we're going to move our machine from geometry, which is right here, to accounting. Just drag and drop, right? It's not complicated. And it tells us there is a template available associated with that collection. And what we'll do, we'll accept it, because what will happen is when our machine is moved to another collection and there is a template, we can assume all the capabilities associated with that template, right? So we don't need to reassign the disk. We don't need to change other properties that we can patch into the template. So that's pretty easy. So as you can see that PC00, right, which was geometry a few minutes ago, right now is ready to be started. And by the way, you can move machines between those collections when machines are running, right? So you don't need to actually shut down the machine. You can actually move it to another collection and only then, let's say, provision the reboot, which will allow that machine to take that new identity. Okay. All right, let's give it a shot. Okay, notice we already have PC00. So that was the machine that we moved, and here we are. Before we had geometry, and now we have accounting. So by simple dragging and dropping it from one collection to another and assuming template capabilities, literally with one reboot, we can get a completely different image, different operating system altogether, different applications installed. We don't need to rely on complex application installation. So things look very, very interesting, right? Let's go towards the automation side of things. All right, so what we're going to do, we're going to launch PowerShell, right? And first, let's see what modules are loaded right now. So what do we have pretty much? And I have a cheat sheet here, so where I'm picking up those commands, so I don't fat finger anything. So notice that we do not have Citrix PowerShell in there, right? So what we're going to do right now, we're going to import Citrix PVS snap-in, right? And if we do run right now, get module, right? Notice that Citrix PVS snap-in is loaded. Let's go and look through all the commands that Citrix gives us for provisioning services, right? So we enumerated all the commands, like for example, ability to add PVS device to domain. By the way, all machines I'm showing here are not joined to the domain, but that's one of the capabilities that actually built into provisioning services. We can have command like get PVS device, so we'll run it in a second, which will list all the PVS devices out there. Almost 180, it's 179 commands that are exposed to PowerShell, right? So it's a very robust and very powerful, right, environment. Now, notice that if we try to run commands against provisioning server, right, and we are not on provisioning server ourselves, right, we're using it remotely. Remember, we had to authenticate through Citrix Provisioning Console to another server, not on this particular, it's not installed on this particular machine, right? So what we will have to do, we will have to actually authenticate with username and the password if we're on a different machine. And here's how it's done. Boom. And if we do run right now command to check the PVS connection, you notice that we are on the server 192.168.1.12, right? There's a port that we're using, 54.321, which is default. And we are connected, right? So username, domain, and passwords are blanked. So we can also get some information about PVS site, right? And by the way, if we're not sure what those commands do, then we can do get help. And let's say get help for PVS site. Well, since I never run help on this particular machine, let's give it a second. Okay, and notice that we do have pretty much synopsis, what that command does, right? Well, let's see, get PVS site. Here we go. So we'll dump pretty much quite a few things out there. At the end of the day, yes, we can give our administrators those PowerShell scripts, and as long as they don't type wrong information in those, right, run them as is, they don't need to go and click on the screen with their mouse, where they can also make mistakes. But this is probably not what we're going to give to our users. Next step, we are going to wrap our PowerShell script into C# class library, and we will consume that class library from two places. We'll consume it from desktop application, happen to be WPF as an example. WinForms will work just fine. And then we'll build a simple web server where we can list information about our farm quite easily and maybe even manipulate it. And the final demo here will be our Microapps application, which might be actually even more interesting. Now we are in Visual Studio. So there are two interesting classes here. So one of them is the wrapper, where we pretty much instantiate PowerShell script. And before that, we do load the module, and we have some parsing facilities that built into this project. And here, this is pretty much a class library that, let's say, if we need to list collections, we can list them. If we need to, let's say, move device to collection, we can move them and so forth. And so what we do here, we just take straightforward PowerShell script and we run it through our wrapper, right? So those are the two classes here, okay? Now, again, as far as object are concerned, so let's say, so this is the collection information that I'm dealing with, right? So I'm extracting collection ID, collection name, description, template device ID, which is kind of helpful. If we need to get to the template and see what the properties of the template are. Total device count within the collection, active device count, whether the device is collection enabled or not, the site ID it belongs to, and the site name, right? Some of this information is redundant, but in case we need to retrieve, let's say, the site name, it's available right away. Otherwise, we'll have to use the site ID and query it from somewhere else, right? Now, also what's notable is template device ID will have a bunch of zeros in it if there's no template assigned. So this is how we can tell if there is a template or not, right? Kind of a quick way of doing it. We have also class for device info. That's pretty much one of the kind of cut and paste from PowerShell, right? So we'll have device ID, device name, device MAC address, description, whether the device is active or active. In other words, device is up or down. Whether the device is enabled, because in provisioning services, you can actually disable collections, preventing devices that belong to them from being streamed. Devices individually can be enabled or disabled. Then associate, again, site ID, site name. Again, this information is redundant, but since we can get it in one shot, we'll just get it, right? And then collection ID that device belongs to. Okay, so what else? Do we have site ID name? And then we do manipulate when we send messages, or let's say we do other tasks. We probably like to know if the task is complete and where it is, right? So there's some options regarding tasks associated with the request that we're making to provisioning services. Also to deal with the Zen objects, right? So we have to pretty much have ability to log on to our server by providing the URI, the name, and the password, right? And the logon object will allow us to pretty much do it. So in essence, in one class library, we pretty much encapsulated all the functionality that we need for provisioning services, where we're going to move machines between different collections, reboot them or shut down, and just supplementing this functionality with Citrix Hypervisor that will allow us to start those machines just for our use case, right? So everything is on one place, okay? And then let's take a look here. So we can close all these tabs. Let's take a look at our WPF application. And what we can do here is that we can list sites. So it's a fairly simple UI here, right? Just click on the button, right? All these buttons again wired with the same event that will differentiate what button ID is, right? So we can list all the collections. As you can see, I have AMD accounting, geometry, history, and a bunch of other collections with associated device count, how many devices belong to each collection. I can also list devices. We can send message to these machines. We can move them in between, shut down, enable, and so forth. We can put nice pretty buttons, right, grids, and so forth. Publish it through Citrix CBAT, and we'll be on our way. Let's kill our application and go to our web server. And let's see if we can start it. Here we go. We have a web browser. And notice we have a wrong input here, right? Well, why is it wrong input? Well, just because we're accessing the default URL and we don't want anybody to be interacting with our form unless we provide the right parameters. Page, which is kind of similar to our WPF application, so we can list the sites, we can list collections, list devices, and we can send message, move devices back and forth. So pretty much a web browser application. Okay. And this is where we're coming to a point where we're going to wire the entire thing with Citrix Microapps. This application is running on my mobile device. You can see it right now here. And it's geared towards educators. So for example, somebody runs different classes. Let's say this minute they run accounting, tomorrow they will run, let's say, history class. Or maybe they need to switch those classes every hour, right? Or maybe they need to have half of the classroom provisioning one flavor of computer images, another flavor. Oh, and by the way, if those machines are used locally, we cannot exclude the fact that some of them can be used remotely as well. So for the most part, all of those scenarios are supported. So let's take a look. Citrix Classroom, that's the app we're going to discuss. Virtual machines with Citrix Hypervisor, that was done with the previous Converge. So if anybody's interested, feel free to reach out to me. It's actually quite an interesting app. We can take snapshots for virtual machines that deliver, for example, VDI images. But let's go to our presentation of the day to provisioning services. And what we have here a classroom, so with a nice clock that allows to change different time zones if we're managing computer classroom somewhere else. And we can hide that clock. But what we have here, we have curriculum and the number of computers associated to deliver that curriculum in a table. So we have accounting, 11 computers, geometry 0, and history 9, right? And that should correspond to our configuration with provisioning services. Notice that we have, how many we have? Actually 11 computers in accounting, that's correct. No computers in geometry, this is a template, we don't count it. And then we should have, yep, we have 1 through 9, so we have 9 computers in history, and template does not count as a computer here, okay? So if we take a look at our hypervisor, we have 2 machines running right now. So we have PC00 and PC10. So let's take a look. PC00 supposedly is accounting, and I believe PC10 was accounting as well. Okay? So what we can do here, and again, if we want to move all machines at once, we can do that. But let's take a look at the options. Let's take a look at what options do we have available. Oh, by the way, see right away that if we select accounting, let's say we're planning to move accounting to, let's say, geometry, we will have a list of all computers currently associated with accounting image. And right now, PC00 and PC10 are running, which corresponds perfectly well to information that we have in our hypervisor and also what we have in our provisioning services. Okay, so we can go through the pages and notice that, yep, there is one more computer, but that computer is down. Okay, so here we can refresh that information because let's say those images were managed from some other system. So let's not take things for granted. Microapps allow you to update the information on a schedule as well. So we can enable it on the backend. We can send a message. Well, let's just do that, right? So let's see. Let me log in into my accounting image, PC00. And then while this, okay, so we're actually good enough. And what I'm going to do, I'm going to send to the PC00 a message. So in order not to affect any other users, what I'm going to do, I'm going to filter the data. Notice if I put PC, just PC in, right? Pretty much all machines that, fulfill that filter will be shown. If I put 1, as you can see, machines are filtered, the ones that have PC1 in them. But we're going to send a message to machine PC00. So here's our message, and let's say we can say your computer is going down. Okay, and we can send this message, and let's see what happens. Now, according to our micro app, the message was sent. Right, so let's take a look. Yep, so here's our message. It tells us that computer is going down. So since we do have PC00 on the screen here, and we did send our warning that that computer is going to go down, so what we can do, we can actually shut down that computer altogether and click apply. Now, notice first, clearly over here, we have a message that the system is about to go down. And then PC00 will go down. So we're actually not rebooting this machine, we are shutting it down. Okay? So if we take a look at what's happening with our machines here, we will notice that PC00 will be down. So it takes about slightly less than a minute. So let's wait. Right, so if this machine is down, let's refresh our provisioning services. Provisioning services comply with that as well. And what we can do here, so just to make sure that we have all our data, right, because it takes a while to reboot those computers, in sync. Let's look at our options, and let's say PC00 is down. Now PC10 was up, so let's leave that alone. And by the way, what we can do is this. We can say, all right, let's move our accounting to geometry. In other words, machines that had accounting image associated with them, we'll move them to geometry. And just to make it more interesting, we're going to put a filter which will make this change executed only with PC00 computer, right? So in other words, that computer that had accounting on start will assume completely different identity. So let's see if we can do it. So what we're going to do right now, we're going to click on change, and from accounting to geometry, we'll move only computers that satisfy this filter. Right? And if we take a look at our table, yes, one machine went to geometry, PC00 actually starting. And if you remember, there was an accounting picture, right, on the login screen. Right, so let's take a look. So what happens, right? So we see attributes of, the fact that the image is provisioned. Yes, the client computer is PC00. And we're starting right now, and let's see what happens. So we're supposed to get the geometry image. And yes, we do get geometry image. And let's take a look. What's inside? This time we're actually running Windows 10. Notice before it was Server 2016. By just one reboot, we're already running Windows 10 machine. So what we're going to do right now, we're going to clear our options, right? And let's do things in bulk, right? So we're going to move all computers in history into geometry, okay? So the currently active image is history. We're going to move it to geometry. We don't need those options because we're moving all of them. Our filter is cleared, and let's click change. So what's happening right now is this. We are reassigning the image to those machines that satisfy the filter. And once that happens, we check the power state. So if machines were running, we're going to reboot them. If machines were shut down, we're starting them up. And this is the case here. We're actually starting those machines up. Okay. Now remember, PC00, we didn't touch it, but we touched all these other machines that are starting up right now. And let's observe them starting up. Notice that management agent is popping up. So that means that machine is online, but management agent is not initialized yet. And when machine is fully ready, that management agent node will go away and we'll see the use memory. And as you can see, and by the way, this is where the time is really handy because it doesn't take that much time to actually reboot it, even with my demo environment, which is not fast by any stretch. All right, so all machines are up. So if we go, let's say, to PC7, for example, randomly, it's geometry. Now, all machines are up and running. And what we're going to do right now, we're going to move geometry to history. All machine states are up, right? Notice there's no history here, so we cannot pull history here because there are no machines with history images assigned, right? So our list was updated automatically. That we see only accounting and geometry as candidates for existing images. And what we're going to do right now, we're going to move from geometry to history. And we don't need to do anything special besides the fact that, yes, we can send messages to those users that those machines go down. And that can easily be done in options, right? So in fact, let's just try it. Let me log in. And we're going to send this message in the batch mode, right? So okay, so we'll say, please save your work. Right, and this machine right now these machines will remap right now to history. By the way, let's refresh it. Because remember, we started them up and we didn't refresh the state, right? If our schedule process was actually happening frequently, that information will be updated for us automatically. But in any event, so once you refresh, we know the power states of those machines. So we're going to move from geometry to history. But before we do so, we can notify everybody that they should save their work because machine will reboot automatically and will assume a different identity. So first, let's send the message to all of these machines, right? In geometry, that will go to history. So what we do right now, we enumerate all machines that are in active state, and all of them will, the ones that are in active state, will get this message. So if machines is down, we're not going to be sending a message, right? So from that perspective, we put some intelligence into this application, but it's a batch processed message notification process, okay? And now the only thing we need to do, just click on change. So we'll go from geometry to history, right? Let's assume we gave our users ample amount of time to save their work, let's say 15 minutes, and then came back with the same app and reassign images to a different, collection. In fact, let's take a look what's happening here. So we were taking geometry to history. So if we refresh geometry, all those machines already moved to history. And those machines right now starting with a different identity. Now let's take a look what's going on. So we're pretty much rebooting every machine from PC00 to PC09. And let's see what's happening with PC10. PC10 was an accounting machine, so let's take a look. Yep. And if we like, we can actually take that PC10 machine and move that accounting to history too. Right, let's see PC10. And we're going to move this machine, just that machine, right? Again, we can send a message that that machine is going down and assume a new identity. And we're going to move just one machine from accounting to history. Okay, so we got our notification message that something will be happening. And our machine, looks like there was some updates due, but in any event, we'll just wait for that. So that image is rebooting. And remember, it was accounting, right? So let's wait and see what happens with that. All right, so we're going through the sequence of network boot. So we see Windows logo. And by the way, in the meantime, let's check what happened to our computers, other computers. Well, looks like all of them are up. So let's just confirm. All of them are history. And let's see what happens to our accounting machine that's supposed to make history. It's still thinking. By the way, as far as Hypervisor is concerned, so all of them are in good shape. Now, our PC10 already booted. Let's see the console. So final stage, and yes, we have history. So as you can see here, by a click of a button, and again, yes, we can go to options, and we can be very, very granular. And yes, we can tell our users to save their work. Wait a little bit. We can possibly integrate with the calendar, where those reboots happen actually automatically. But we do have fairly good capability here to move computers between classrooms. In other words, in 1 minute, you can change one flavor of the class to another. And it can be done very granular. And let's say if we go home and we need to shut everything down. So let's see. So accounting, right, has 9 machines. So what we're going to do, we're going to shut down accounting because we're about to go home. Let's remove the filter. Let's see how many machines are there. Let's say refresh. I will know in a second if those machines are up or down. All right. So what do we see? So we see that accounting machines are down. History machines better be up. Yes, they are. You'll have 2 pages of them. And what we're going to do right now, we're going to shut down all these history machines. All the history machines will go down right now. Okay, so if we take a look at our hypervisor, you'll pretty much see those machines disappearing one after another. Let's do a refresh. Yep, all these machines are down, and we ended up with 11 machines in history and 9 machines in accounting. And yes, all these machines right now are shut down. We have 2 pages, pretty much all these computers are accounted. And when we come back and we need to start, let's say, a geometry class, we can easily do it from here through the cell phone. No extra components, no VPNs, by the way. Nicely encrypted. We can do it from PC, we can do it from the Mac. And we can possibly add some other functionality, but at this point, it does appear to be fairly self-contained, following kind of the mantra of a micro app that we don't do too much, right? We just do a few things and do it well. And we do hide complexity quite a bit, right? And making things very, very efficient. Thank you very much. Enjoy Converge.